Hello and welcome. I've got a fun one for you today, and probably going to have to be a quick one because I'm meeting someone soon, so I'm going to have to speed run this one a little bit. This is a problem called Square of Fortune. It's from one of the live battles that the FMWC put on at the Global Excel Summit last month. And I'll put links in the not the comments, but that other thing that talks about the video, to where you can see the original live battle and some other details about it. So, simple idea. Square of Fortune might or might not be inspired by a certain real life game that need not be named. Case author is Joseph Palisoc. Joseph has the unusual distinction of being the only person so far who has beaten me in one of these live battles, although I'm sure I won't be able to keep that up for much longer as there start to be more of them. But he's also writes very interesting cases, including this one. So, basic idea is you've got a word that two players are trying to guess, and so there's the sequence of letters in the order that they guess them. So let's say in this case, I think sum is one that starts out reasonably. So sum, the first player starts off by guessing M. They get a hit. So then, depending on the spins, which I'll come back to in a second, they get a certain number of points, and then the second player guesses U, they get a hit, so they get some number of points. Then the next player guesses Q, they get nothing, N gets nothing, and so on across until somebody guesses the last letter, and then that player wins the game and gets some number of points according to what they've built up along the way. And how the points work is basically you have this little wheel that you spin. So it starts off pointing at 90, and then you spin it each turn. So whatever, let's say you spin a 3, so it turns 3, so it gets to 100. Then you next time you spin a 2, it starts from that place, so you spin 2 more, it gets to 140, then you, I don't know, spin another 7, it goes 2, 3, 4, 5, 6, 7. I may have got that one wrong, but anyway, you get the idea. So basically there's a series of spins. Sorry, they're not all there for the first couple of sets, but here. So first you spin a 6, then a 20, then a 6, then a 17, and so on. And wherever that lands, that's the number of points that the thing is worth. So I've made this little tracker inspired by what they had in the live battle to see how I'm actually getting on. I've linked it to the answer sheet, so we'll see if I'm getting them right. So let's do some quick calculations. Oops. So first thing I'm going to want to do is have a game picker. I'll start with sample 1 because that's always a safe place to start. And then what I'm going to want to pull in for each game, I'm going to want to pull in what's the word, what's the sequence of spins, and what's the sequence of letter guesses. So first thing, I'll just get the row. I'm just going to match that against here, and it's column B. Then the word is in column E, C3. And obviously in the early ones you don't have a word, so when I change this to, let's say, sample 3 later, then there's a word in there. So then next thing I want is the sequence of spins. So first I'm going to index on here. So on these 26 columns, H to AG. I have to fix that because there's merged cells. And then the row I want is this one, C3, and column 0. That gives me every column, and then I'm going to lay my model out vertically, so I'm just going to transpose that. So that's my sequence of spins, and then based on the sequence of spins, well, hang on, first let's just pull in all the data. So then I'm going to pull in my sequence of letters guessed, and same idea, I'm going to transpose index that 0. This time the range I'm pointing at is these cells over here, so AI to BH. And that one, it does just work. So there's my letters, and I'm just going to put in and double quotes so that when I'm on, say, sample 1 where there are no letters, it doesn't freak out, it just shows blank. Okay, so now that I've done my spin, I'm going to figure out my offset. So basically my offset starting from 90, so I spin 1, I get to here, I spin 2, I get to here, all the way up to, if I spin 23, then I get back to 1 before it, and then from 24 on I'm back to where I started. So in other words, 24 is equal to 0, so what I'm going to want to do is I'm going to take a mod sum. Starting from there, I'll lock in the 6 so that it expands, and then mod that 24. So Again, we're on sample 1 here. Let's go on to something that has multiple spins. So here I spin a 21 and then an 18. So you add those together, that's 39, which is going all the way around once, and then another 15. And then you add 15 to that, that gets you to 30. That's the equivalent of going all the way around twice, and then adding another 6, and so on. So then my score. Now this comes one of the fun parts of this thing is trying to unwind this square into something that you can actually use. So let's do that quickly. So there's 24 pieces on it. It's 6 to a side, or 7 to a side, but the corners repeat. So I'm just going to say sequence, comma 24, so I can lay it out neatly. And it starts off at 90. So it starts off at this one here. And then I'm going to transpose this bit here. So those bits are easy. Now the challenge is, of course, then you have to keep going clockwise. So now you're going in reverse. So for these next 6, I need to go backward. How am I going to do that? I'm going to say equals index this, and then I wanted to basically count down 6, 5, 4, 3, 2, 1, and I've got my row numbers here. So I'm just going to say 17 minus these 6 numbers there. And that counts down 80, 150, 60, 58. Yes, good. So that's working. And then I do basically the same thing here. I'll say index on, index, try again, on this bit. And this time it's going to be, I guess, 23 minus, so that I get 6 for the first one. 23 minus that. And that goes 70, 140, 130, down to 50. Good. And then for the last 2, I just need these ones here, and that all works out. Change format along the way for some reason. Okay, so that's my square unwound. So now my score is going to be index. Now I'm offsetting from 90. So in other words, an offset of 0 is actually column 1, an offset of 1 is column 2. And that works nicely with the mod function, because let's see, do I have any zeros in here? Anyway, if you get to an exact multiple of 24, this offset is going to be 0. So those two work nicely together. So we do that. That gives the score associated with each one. So in other words, I spin a 21, I guess an F, and that score is 80 if I get it right. I spin an 18, I get a T, the score is 80 if I get that right. I spin a 15, the score is 140 if I get it right, and so on down. So now I want to know, did I get it right? But I'll just show you quickly here. So first, we're just interested in how far does it spin. So we've worked that out. That's fine. Second, I'm interested in when does the last letter get found. Fine. Then the score of the player who solves the puzzle. Then here, words have repeating letters, and you can get 2x or 3x points if the letter appears multiple times. So I could just do a check of, is the letter there? But instead I'm going to say count letter, see how often it appears. So a handy trick for that, if you want to see how often a letter appears in a word, you can say the length of the word minus the length of the word you get if you take all of that letter out. So, sorry, I should be locking in the column for both of these. Sorry, the row I mean. So in other words, you take or and replace all the F's with nothing, and you see how much shorter that makes the word. And so let's just go to a level where there are repeats. See, 62 is upper. So then I should, oh, whoops. Oh, sorry, I forgot to put in my +1 here. I talked about it and then I didn't put it in. So that's why. That's spill error here, just to kind of explain. When you index something 0, that means you're taking all, so I'm indexing on a single row here, so 0 means I'm taking the entire row, and then it's trying to spill the results out into this whole array, but there's something else here, so it's giving me a spill error. But in this case, that's just a reminder that I haven't put in the correct +1. So let's just do a quick check. So let's go back to sample 1, because I think that had a simpler start. So if I spin by 5, so I start off at 90, so I go around 1, 2, 3, 4, 5, and I get to 140. Good. So that is behaving the way it's supposed to. So let's go back to where I was then. I think it was 62 was upper, and where's it gone? Where's P? Yeah, they're not in alphabetical order, of course. Oh yeah, here it is. There's my P, and that gives me a 2. So that's good. So then the score is just going to be the score based on the spin times the number of times the letter comes up. and then the last thing I need to figure out is the player. And for this one, in the very last level, in level 5, I think, yes, in level 5, if you guess the letter correctly, then you keep another turn. Otherwise, it automatically switches. So it's always player 1 first. I'll just quite a stickler for having the same formula in rows and columns, so I'm going to highlight that in red because that's different. That's just a hard code. And then let's just see, what is the first row? 152 is the first row. So we'll call it keep turn, to just say if you're greater than or equal to 150. Did I say 152? I think I said 150. Yes, 152. So in other words, you keep the turn if you guess right. If this is true, otherwise it's false. So then I'm going to say equals if this is greater than 0 and we're keeping the turn, then that, otherwise 1 minus that. Sorry, not 1 minus that, 3 minus that. I'm used to switching between 1s and 0s, but here I want to switch between 1s and 2s. So here we go, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Now if I go to, let's say, sample 5, one of the games in the last turn, here's someone getting it right. Whoops, sorry, no, so it's based on whether they got it right on the last turn, not on the current turn. So try that again. So yeah, so player 1 guesses E, that's part of the word, which is text, that's fine. Then player 1 gets to guess again. Okay, so then player 1, 2 points, and it's just going to be some ifs, score, where player is this, and that's this one gets 80, this one gets 300, and then the last little twist is we need to know which player wins the game, so finish. And for that I'm going to say, let's see, so I want to know which player number is next to the last one of these that's greater than 0. So do I have an index here somewhere? I don't. I'm going to add in an index. So we'll just put in sequence. There are 26 ones in every game because there's 26 letters to guess in different orders. So now first I'm going to get on what turn it ends. I'm going to do that with a max ifs. So the max of that where the score is greater than 0. Whoops. And that will give me the index, so it finishes in this game on turn 24, and then I just want to go to row 24 of the list of players. Now I'll just note that I've got this mix of, an array, a dynamic array, and then these locked in things. If I was going to copy this formula into different places, I'd have to be more careful about that. That's not good. Oh, sorry. Okay, put that totally the wrong way around. So cut that out, put it back over here. So I want to index that on that. Okay, and so here we go. I've got in row 24 where it finishes, it's player 2, and then so in the top level, it says you double the score of the player who finishes. So I'll just call this adjusted points, and I'm going to say this times 1 plus this equals this. So in other words, if this evaluates true, you add it to 1 and it'll get 2, otherwise it'll be 0. So in other words, player 2 got the last score, so we double player 2's score. And then I think I've done all the different bits of plumbing, so now let's just start answering questions. And obviously I've only set it up to run once, so let's sample 1, 2. I'm just going to set up a quick table here to get all the answers. So that, and then sequence 100 for the actual cases. So the first thing that I need to know is the number of points. So that's the number of points on the first spin, which is this one here. Then for question 2, I need to know on what turn will the puzzle be solved. Oh, so I actually should have made this a separate piece. Let's just put it in here. Last turn. So I just want to know what is the last turn. For question 3, I want to know the score of the player who solves the puzzle. So that's just going to be index. So the player who solves the puzzle is the one who gets the finish. So it's just index that. And then question 4, same thing again. What's the score of the player who solves the puzzle? And then question 5, what's the score of the player who wins the round, which is the one with the higher score. So just max of those two. So then that should set me up for everything. Now I just need to data table. My column input cell is the game name. And then I hit calculate. Some of these don't have a value. That's because there are parts of the game that don't exist at level 1, but let's just see if it's now working. So first things first, I can check that I got the sample answers. So sample 140, yes. And then I can fill all these in like that. Sample 2, the answer should be 24, and it is. So then I can fill all these in, starting from number 21. Sample 3, the answer should be 250, and it is. Good. So then I want this. Should probably really have just set this up with a lookup so I didn't have to manually scroll and find these every time, but never mind. So then I want that one to point to the next row, so 71. Let's go to 72 instead of 82. Copy that down. And then the last one, I want the answer to be 600, and it is. Good. So then finally, I'll just point all of these over here, starting at 81. Fill it down. So let's check my. Oh yeah, I got them all right. Amazing. I was hoping I was going to avoid having to do some debugging there. All right, so that is how to do it. Just a quick word, which is, I think I've talked before about how these problems with the data laid out like this sort of lead you to a natural. The first trade-off you have to make in the game is, do I lay out a whole calculation sheet and then do a data table at the end to get all the answers, or do I just try and do everything in row? I won't go through every single piece of it because it just is going to be a little tedious if I make you watch me do the case all over again. But I will say that on this one you can actually do it all in row if you want. So for example here you can say index, where's my, should probably have given this a name, but never mind, I was in a rush. So here is just index that plus 1, and hopefully we'll confirm that we're getting all the same answers. Those all match. Here, on which turn has the puzzle been solved? So this one is just going to be max of match. So I'm basically going to match each letter of this against the list of letters guessed. So how do I get the list of letters? I go mid of this, sequence, length of this. So that returns everything, in this case 1, 2. If it's a 5-letter word, it returns 1, 2, 3, 4, 5. And I want one character starting from there. That's the mid. Match that against this list, 0, and then take the max of that. That gives me 24 there. And copy that down, and again that matches. And it gets a little bit more complicated later on, but not enormously so. So here you'd basically need to add a new section. So you'd say index, that's score grid up here, mod sum. So same logic as before, but this time I'm just starting off here and anchoring the column. Mod that 24 plus 1, and that's the score for that piece. And then you can say times 1 minus is error search. So I'm basically saying, is this letter in here? And if that's an error, then that zeroes it out. And so here I've got a score of 120 here and a score of 130 there. And so now I just want to say, yeah, I guess I'll need a last move as well. So that'll be max ifs. Oops. So it'll be the max of the index where this is greater than 0. Fill that in, and then I can say something like equals sum if mod this 2 equals mod this 2. So in other words, mod 2 is just saying 0 or 1, it's matching the parity. If the parity matches the parity of the last move, then that score is part of that player's score, otherwise it's not, and I get a 0. And that matches there. Oh, no, that one, now I'm not matching. Oops. So I've stuffed something up there, but anyway. All right, I can't resist the urge to try and figure out what's wrong now. So let's see. So in this case, 14 is right, so we're getting on the 14th letter, and there's a 2 and a 4, so something is not, probably, oh, I didn't lock in the rows for this piece. Okay, and now we're matching there. And anyway, like I said, I'm not going to make you watch me do the whole thing again, but you can do the same thing here, that basically, here you would then, rather than just multiplying by is it a match, you could use that same lens substitute thing to multiply by that to get the scores with the weighting. And then down here, you do the same thing, except after doing the scores with the weighting, you could then add up, you'd need another block then, another 26 column block to determine whose turn it is, which would look just like, the logic would look just like that one. And then, you can sum up player 1 total score across the row, player 2 total score across the row, and basically recreate this little bit up here. So yeah, this is, I feel like in most of them there's a, you can't always realize it at the time, but in most of them there's a clear kind of better choice, that either it'll work doing it in the rows and you can cram it in there and take up less space, or you need the kind of wide open space of a fresh sheet. This is actually one where both methods work. All right, I think that's all I've got for today. If you enjoy this kind of stuff, then you're welcome to subscribe, but I won't be sad if you don't. Have a good one. See you next time.